Hello, math students, and thanks for tuning in to the lesson on absolute value equations. Please pardon the shadow coming right down our paper here. The sun is shining, and I can't quite get it to go away, so we're just going to work around it. So absolute value. So you've seen absolute value before in your math past. I'm just here to review it today. The definition that I put for you here, we're going to read together. It says the absolute value of a number is the number's distance from zero on a number line. Well, that seems pretty easy. So the absolute value of a number is the number's distance from zero. I'm going to highlight over that. Keep that in mind, distance from zero. Okay, so and the math notation to indicate that you're dealing with absolute value are these straight vertical bars. So when you see these straight vertical bars wrapped around a number, so it's not soft parentheses, straight bars wrapped around a number, you know that you're being asked to find the number inside's distance from zero on the number line. So let's take a look at the absolute value of 4. So I've got a number line here. Let's go over to 4 and kind of mark that spot with a point. So there's 4. Now the question is, how far away from 0 is that number? So let's also mark 0 here. Kind of X marks the spot. So how far away is that point from 0? Well, I think it's pretty clear that it's 1, 2, 3, 4 units away from 0. So the absolute value of 4 is just 4. Seems pretty simple. Okay, let's go to the next one. The absolute value of 3. So in words, what are we asking? Well, we're heading out to 3, and we're measuring how far that is from 0 on the number line. So that distance is 3. You're probably thinking, what the heck? This is so easy. Okay, let's look at the next one. The absolute value of -5. Okay, so we earmark -5 on the number line right over here. Let's see if I can kill this shadow a little bit. So we come over to -5. Okay, put our X marks the spot on 0. Let's measure that distance. Boom. Okay, so how far away is that? Well, it's 5 units away. Granted, I know it's in the leftward direction. I get that. We went left. But how far left did we go? Well, we went 5 spots. 5 units, 1, 2, 3, 4, 5. So we only went 5 units. That's the distance. So the absolute value is just 5. That's the distance. The -5, I mean, that's just telling us we went left, but absolute value doesn't care about direction. You know, when you drive in your car, you don't say I went -3 miles if you went south. You just say I went 3 miles. Doesn't matter what direction you went, north, south, east, west, you went 3 miles. So if you think about distance in the real world, like when you're driving, you're always kind of dealing in absolute values. Okay, next one, the absolute value of a -1. Okay, so let's go to -1 and mark it. X marks the spot on 0. That distance, although in the leftward direction, I get it, we went left, but the distance is just 1 unit. Okay, so distance from 0. Okay, so what are we going to do with this? Well, in Algebra 1, now that we've reviewed the meaning of absolute value, we're going to try actually solving equations with absolute value, because that's what we've been studying in Unit 1, solving equations. But now we're going to solve equations that have absolute value involved. So let's take a look at example 1. It says solve for x. Okay, so we've got the absolute value of x is equal to 5. Now remember, x, we got to think here. Let's just think logically. X is just holding the place for a number, right? That's the only reason we have x. It's just holding the place for an actual number. So we've got to think to ourselves, and I'm going to write this down in words. This is what we've got to think to ourselves. What number, okay, because that's where the x is, what number has a distance from 0 equal to 5 units. That's what is being asked here. When you're saying the absolute value of this number is equal to 5, you're basically saying, hey, what numbers can go in here that when I find the distance from 0, that distance is equal to 5 units? What number has a distance from 0 equal to 5 units? So let's think of a number line. Here's 0, X marks the spot. So what number's distance from 0 is 5 units away? Think about that. You can pause the video and think about that. And hopefully what you're thinking is, well, 1, 2, 3, 4, 5. Here is a distance of 5 units. So one number that can go in there is 5. The absolute value of 5, well, the number 5 is 5 away from 0 on the number line. Okay? But guess what? There's another number. If you go left 5 out here to negative 5, that also has a distance of 5 units away from 0 on the number line. So another number that could slide in here for X would be negative 5, because negative 5 is 5 away from 0 on the number line. So whether you're at positive 5 or negative 5, either one of these, you are 5 units from 0 on the number line. So the answer to this problem, what's X? Well, X can be a positive 5, so a positive 5 can slide in there, or X can be a negative 5. Okay? All right, let's flip it over. Here's the next one. It says solve for X. The absolute value of 3x minus 5, oh, sorry, slide that down. The absolute value of 3x minus 5 is equal to 15. Okay, so let's think about this. Something we're going to slide in here for X. When I triple it and subtract 5, whatever I get here, its distance from 0 is 15 units away. So I almost think of it like this. If I draw a number line, okay, here's 0. We always measure from 0. My thought process is, whatever this is, in the end, 3x minus 5, when we get a number inside those bars, that number has to be 15 units away from 0. So this number, all of this, either has to be a 15 or a negative 15. There's only 2 numbers in the whole wide world whose absolute value is equal to 15. It's either 15 or negative 15. Okay? This is a distance of 15 units. This is a distance of 15 units. So this quantity here either has to sit out here at 15 or back here at negative 15. So what ends up happening is we set up 2 equations. This stuff, I'm going to call it stuff. This stuff inside the absolute value bars, so 3x minus 5, must be situated at positive 15, so it's 15 away, or it must be, all of it must be situated at negative 15. Okay? And I mean, you can guess and check this too, guys. I mean, you can play around here. Like, you can try to think of values for X that would make this a true statement. Like, we could sit here and say, okay, like, is X 5? Maybe X is 5. Well, 3 times 5 is 15. 15 minus 5 is 10. The absolute value of 10 is not 15. Maybe X is 20. Let's see, 3 times 20. That's 60, minus 5 is 55. The absolute value of 55, that's not 15. So guessing and checking could take us a while. But if we know that this stuff has to be 15 or negative 15, then we can set up the equations and just get it done much faster. So to solve this guy, I'm going to add 5 to both sides. So 3x equals 20. And I'm going to divide by 3. And that's going to give me x equals 20 thirds. That's one of my answers. Or over here, I'm going to add 5. Add 5. So 3x equals negative 10. And if I divide by 3, x is going to equal negative 10 thirds. Ooh, so not the prettiest of answers. I don't know if I would have come up with those guessing and checking. Now check out how this works. This is so cool. So check this out. In order to check this, let me get a different color pen here for us. In order to check this, let's start by plugging 20 thirds in here. So if I take the absolute value of 3 times 20 thirds minus 5, let's see if we get 15. Well, 3 times 20 over 3, these 3's are going to cancel. So I just have 20 minus 5, and that gives me that 15 I knew up here would be true. So if x is 20 over 3, then the absolute value of 15 is 15 away from 0 on the number line, and so that checks. Similarly, let's try the negative 10 thirds. So if I do the absolute value of 3 times negative 10 thirds minus 5, does that equal 15? Well, let's see. These 3's are going to cancel. Negative 10 minus 5 gives me negative 15. Well, is the absolute value of negative 15 equal to 15? Yeah, it is. Negative 15 is 15 away from 0. So that also checks out. Very nice. Okay, let's look at example 3. Solve for x. The absolute value of 2x minus 1 is equal to 4. So again, this stuff right here, if its absolute value is equal to a 4, then it has to sit at either 4 right here with a distance of 4, or it's got to sit at negative 4 with a distance of 4. So 2x minus 1 has to be over here at 4 or back here at negative 4. So I'm just going to set that up. So 2x minus 1 has to equal 4, or 2x minus 1 has to equal negative 4. Now, maybe you're seeing a pattern here. I kind of hope that you are, because this is a trick, it is a rule that I'm okay if you use once you understand the true meaning of this. Basically, do you notice what we did here? You take the stuff inside the bars. You set it equal to the positive 15 or the negative 15. Look what we did down here. You take the stuff inside the bars and you set it equal to 4 or negative 4. So let's solve this down. So if we add 1, we get 2x equals 5. Divide by 2, divide by 2. You could leave that as 5 halves, but that's an easy one. That's just 2.5. So one value of x could be 2.5. Over here, add 1, 2x equals negative 3. Divide by 2, and that's going to give us negative 1.5. So those are my two answers. And if you check these, if you plug these in for x, indeed, it's going to make true statements. Okay. Example 4. Now, example 4 gets interesting because it says solve for x, and notice, though, there's a lot of stuff going on here outside the absolute value bars. So what I want you to know is that when you have a more involved absolute value equation, you must isolate the part of the equation that's got the absolute value before splitting it apart like we're doing up here. So it's simple to do. You know how to solve equations. The first thing you'll do here is add 5. So just add your 5 over to the other side. That's going to give you 2 absolute value of 2z plus 4 equals 16. Then we want to get rid of this 2 in the front. So we're going to divide by 2 on both sides. which is going to give us the absolute value of 2z plus 4 equals 8. And now we're ready to roll. You have your bars isolated. So if 2z plus 4, if the absolute value of it is 8 units away from 0, then this 2z plus 4 can either situate itself at 8 or negative 8. So we'll write those two equations. So 2z plus 4 has to be over there at positive 8, or 2z plus 4 has to be at negative 8. Now we just solve these equations. So for this side, we're going to subtract 4. So 2z equals 4. Divide by 2. Z equals 2. Over here, subtract 4. 2z equals negative 12. And divide, and we get z equals negative 6. So those are our answers. Z equals 2 or z equals negative 6. And again, I won't take the time on the video to check, but if you substitute those back up here for z, you're going to have true statements. And the last one I wanted to bring to your attention, it's more of a trick than anything. Check this out. It says solve for x. The absolute value of x plus 5, they have it set equal to a negative 3. Okay, guys, this is no solution. And I want you to think about the reason. Pause this video and think about why. Okay, if you truly paused it and thought about it, then you would know that distance from 0 can never be negative. Distance is always equal to a positive. So there's no solution to this. You're never going to find the distance of this and get it equal to a negative 3. So if they ever try to trick you like that by putting absolute value equal to a negative, you simply respond with no solution. Okay, thanks for watching.